I want you to look closely at three specific objects and see if you can identify the hidden connection between them. The first is a cluster of delicate, translucent salt crystals formed into sharp, near-perfect cubes. The second is a heavy, jagged piece of gray granite pulled from deep beneath the earth. And the third is a rough chunk of raw copper ore, shimmering with metallic veins and spots of green oxidation. On the surface, these materials appear to have nothing in common. They share no single color, texture, or origin. To an observer in the 8th century, they were entirely separate entities with no reason to be grouped together. This was the reality for early alchemists. In the 8th century, science operated without standardized labels, universal measurements, or shared rules. Researchers typically categorized materials based on surface traits. If a substance was white and powdery, it was filed away with every other white powder, regardless of its chemical makeup. Because appearances are often deceptive, two researchers working with the exact same compound would call it two different things. This made it nearly impossible for one scientist to replicate another's experiment. Without a shared system to identify and categorize these substances, scholars were often trapped in cycles of trial and error, unable to reliably build upon one another's discoveries. An 8th century scholar named Jabir ibn Hayyan recognized this flaw. He wasn't interested in just mixing potions, he was obsessed with finding a structural logic to the physical world. Geber realized that for alchemy to become a reliable discipline, scientists had to stop collecting random observations and start organizing them into a consistent framework. He introduced a new methodology, ignoring outward appearances like color or origin entirely. He argued that human sight was too subjective to serve as a basis for classification. Instead, he shifted the objective of his work toward establishing rigorous, repeatable testing to see how materials actually behaved. Jabir took materials like our salt, our granite, and our copper ore and subjected them to intense heat inside stone furnaces and corrosive liquid baths. He documented how they reacted compared to other substances. Certain liquids, which he called volatile spirits, would rapidly boil away and vanish into thin air when heated. Our three objects did not. He then compared them to pure metals, like gold or silver. While the metals would melt into glowing liquid pools, our three objects remained stubborn and unyielding. His testing revealed the hidden trait. While spirits vaporized and metals melted, the salt, granite, and ore remained solid and stable under extreme thermal stress. Because they shared this physical behavior, Jabir grouped them into a single unified group he called the fourth category. He had proven that a material's identity is defined by how it reacts to pressure, not how it looks to the naked eye. This was more than a new list. It was the world's first logical system to test and compare the physical Earth. By grouping materials by behavior, Jabir moved chemistry away from subjective guesswork and toward a discipline based on standardized, objective testing. This behavioral model was so effective at predicting how materials would function that it survived in scientific texts for 12 centuries. The logic of grouping substances by their shared chemical reactions remains a core principle of how we study the universe today. This image shows a modern geologist in the field. To classify this stone, he doesn't just look at its color. He uses hammers and acids to test its physical and chemical properties, following the same logic Jabir established. Inside a modern chemistry laboratory, researchers use digital sensors to analyze crystalline structures, continuing the work of identifying materials by their shared behaviors. By looking past visual noise to uncover how materials react under pressure, Jabir ibn Hayyan established a logical system that researchers still use to map the physical world.